Yo guys, how's it going today? So today I got back my math midterm from last week, and I'm going to share with you my grade and how I felt about my mark and my thought process in general. So here we go. So out of 20, I got 14. I got a 70%. And according to the bell curve, this is around a B range. I'm apparently there I'm in the top 30 to 35 percentile. You know what? After everything that's happened this semester, I can't even cry. Like 70 is pretty damn good. One of my friends, his name was Make Pie. He told me that like he this was his exact words. He was like, I averaged a 65% my first 3 years in undergrad. For engineering, the grades don't mean jack. And I couldn't agree more. So the average was a 60%. I got a 70, 10% above average. You know, not bad. I used to always get 80s or 90s back when I'm in my first or second year math. But now, like when you go to third year up, it's like far more rigorous. It's like I would describe the math journey like cresting a hill. So it's like let me think. Grade pre-calc up until from kindergarten to pre-calculus 12, everything was like a flat normal line. Everything was perfectly easy in terms of difficulty. Then you go to calculus. So let me try. So like this up until pre-calculus 12, it goes something like this, or my cursor. Then it goes like a steep bump when you go to calculus 1. And then it's like this, like in terms of difficulty, calculus 2, slightly more, calculus 3, slightly more difficulty. Linear algebra and ODEs, same difficulty as calculus 2. And then this course is like, boom, massive, suddenly way more challenging. I think part of it has to do with proofs, and it gets harder to visualize since you're in the complex world and such. But yeah, let's dive into these questions. So question 1, show that z naught equals 0 is a pole of this function and determine its order. And B, use residues to find that 1 over z cubed times z plus 4 dz, this integral, where c is the circle radius 2 centered at the origin. So I got full marks for question 1. I just applied this phi formula and then said phi of z is 1 over z plus 2. It wasn't that difficult, this question. Yeah, f is a rational function. Rational functions, as we discussed before, are analytic everywhere except where the denominator is 0. So yeah, part B, I did, yeah, so it's like 1 over z cubed multiplied by z plus 4. Yeah, so then you're considering it around z equals 0. So just do 1 over z plus 4. Like I said last week, the singularity z equals -4 is outside c. So you only consider z equals 0. So yeah, z equals 0 with a pole, it's an order m equals 3. So the residue, take the second derivative of phi, and then order 3, so it's 3 minus 1 factorial. You get 2 times 4, just plug it in, you get 1 over 64. 2 pi times 1 over 64 is pi over 32i, and that's the answer. I just calculated the derivatives for phi down here. Yeah, the average for the first question, I got 100%. The average was an 82%. Yeah, it was pretty high. 82.9, yeah. Question number 2. Honestly, my teacher's kind of an a-hole in grading. He sometimes like nitpicks the smallest things possible, and it kind of pisses me off, I'm not gonna lie. Okay, you'll see what I mean in a second. Show that f of z is equal to, it's a piecewise function, 1 minus cos z over z squared, z not equal to 0, and 1 over 2 for z equals 0. And show this is entire. You may take the series for cosine as known and the fact that G equals cos Z is entire. B, find the Laurent expansion about Z naught equals 0 of this function, valid in the region, explain why it's valid there. So for part A, I actually got the grades back for this yesterday, but the only reason I decided to present this video today was because I actually tried to appeal for a mark and a half higher. I remember I said to my professor, oh, please, a 77.5% looks so much nicer than a 70. I really want a 77.5%. And then Tom, my professor, was like, yeah, I'm sure you'd want a 77.5. I'm also sure you'd really want a 99 or 100. So I'm like, yeah, I'm not going to argue anymore. So let me show you my approach. You've seen it before. I basically tried to show that the limit of this 1 minus cos Z over Z squared is, as it approaches 0, is equal to 1/2. I used L'Hopital's rule, and I did get 1/2. And since it's 1/2 here at Z equals 0, I proved that F is continuous across the entire complex domain. This is a necessary but not a sufficient condition. Then I took the Maclaurin series for cos Z and got 1 minus Z squared over 2 factorial plus Z4 over 4 factorial, so on and so forth. And then I did 1 minus cos Z over Z squared. So then you plug that in, you get, after doing this, 1 minus this series over Z squared, you end up with 1 over 2 factorial plus Z squared over 4 factorial minus Z to the power 4 over 6 factorial. This goes to show that Z equals 0 is a removable singularity. And then I said 1 minus cos Z over Z squared has now been reduced to the sum of polynomials. Polynomials are entire. And based on this reasoning, F is continuous throughout C and F is entire. And then he wrote this vague thing. So I tried to go and talk to him about it, but then he was like, something like, he was like, yeah, but you didn't connect it or something. You were supposed to show, I forgot the solution key, but he was like, you were supposed to show that, what you would call it, the Taylor series, like when you plug in x equals 0 at this Taylor expansion that you drew, or Maclaurin or whatever, you also get 1 over 2. So for that reason, I docked a mark off you. And then he's like, the sum of polynomials. I'm like, he's like, that's not right. I'm like, what are you talking about? It's right. And then it's like, you're seriously gonna make me lose marks over a single thing that I didn't include? Like, honestly, if I was the professor and I'm marking this, I would give myself full marks, honestly. And then he's like, hey, on the bright side, at least know what to write for the final. Ugh, forget it. Part B, yeah, this one I wasn't entirely confident I'd get full marks. I just did a bit of substitution, but apparently the answer key said something about substitution. I do want to have another chat with my professor, but I think he's going to be annoyed if I keep appealing the same questions over and over again. Yeah, I basically said that 1 over Z plus 1 is 1 over Z over 1 plus 1 over Z. And then I factored out the 1 over Z out to the front and then did something like this, as you could see. And then I was able to show that it was valid from 1 to infinity. And the reasoning was because of substitution. I have to ask him about this, or just read the solution. Yeah. Question 3. Yeah, so I didn't lose any marks for 3A. He gave me full marks. He understood what I was doing. So yeah, that's saved. For 3B, yeah, he said he didn't really want to give me, like, he's not going to change this mark. My reasoning for this question where the limit, like f has to be a constant, was I said the degree of f should be 0 and such, because like for this, f has to have a degree of less than 1 for this limit to be true, and that power, the degree actually has to be 0, because like if you had any other number like 0.25, you'd probably get like a it wouldn't be continuous throughout the entire complex domain, and thus it wouldn't be analytic nor entire. I'm gonna have to ask I could just read the solution, but I don't exactly remember why I lost marks on this one. Part 4. Okay, so apparently I got B and C correct. I'm going to talk about B and C first before I talk about part A. For B, yeah, I got it correct. I just said Z equals 0. It has a pole of infinite order because of like e to the power of Z gives you like this series. So e to the power of Z, 1 over Z, do substitution, and then you end up with something like 1 plus 1 over 2 factorial Z squared plus 1 over 3 factorial Z cubed, so on and so forth. And yeah, he was generous here. So I'm not going to go to him and ask him to take marks off me. That's I'm just going to get away with this one. I remember he told me, he was like, Brent, in my 20 years of teaching, I only had one student come up to me and tell me that I gave him too many marks. But that was okay because he was already acing the course at that time. Yeah, so I'll have to reread the definition of an essential singularity. But yeah, I got full marks for this. For C, well, the answer to C is pretty much to A. He wrote okay, like I didn't give the exact definition, but he still gave me the marks. Like apparently you were supposed to use the term, I read it in the answer key, it was like path of deformity or something, like basically saying that C has like this integral value. So the box outside, it contains the original circle. So it gives you the same integral. I'm pretty happy about B and C. For part A, yeah, I BS'd on this one. It was if F is analytic in a bounded domain B except for poles, explain why the set of poles have no accumulation point. Yeah, I basically I said something like this. Not sure if I can annotate here, but let me switch to the whiteboard. Give me 1 sec. So I did something like this. Show it has no. So I said if it had some C here, like let's just call this C, and then you had an accumulation point where it wasn't analytic, then the neighborhood does not contain the accumulation point and it's in C, but that this particular point where my cursor is pointing to is not. Like I'm not that good with proofs. Like I can visualize them in my head, but when it comes to putting them down on paper, I get a little sloppy at times. Yeah. So all in all, this midterm wasn't that, it's not great, but after everything that's happened, it's not bad. Like every second midterm is usually the hardest. In my experience with my entire undergraduate experience with math courses, the second midterm always screws me over. And this one is relatively higher in terms of the second midterm rounds. So yeah. Well, that's all for today. Comment on this video if you want to see more videos like this. I'd love to stay, but for now, I gotta jump. I'll see you guys on the other side of the bridge. Catch you next time.